All right, guys, welcome back. Another lesson, another part of the year we're going through. Systems of equations. This is a whole unit, actually. We do a lot of stuff with systems. So this is just kind of a review of the basics, okay, seeing what you remember from Algebra 1. So today's focus is just graphing. Okay, how can we solve two equations at once just by graphing? And the answer is right there. It's up on the picture, up on the board, the TV. Okay. If I were to graph both of these lines, here and here, I look to see where they intersect. That point of intersection is the answer, the xy point, that will satisfy this equation and this equation. Okay, so that's what we're going to be looking at today. So like I said, should be a review from Algebra 1. So we went ahead, we graphed and solved linear equations. Today we're going to solve a system, and then we're going to classify systems of linear equations. Okay. So, was it working? Just as a quick thing as well. So, like I said, today we're just graphing. The next video, I'll do substitution elimination. How else can we figure out what number can go into both equations by using those methods? So, we're going to talk about what a system is, what does consistent, inconsistent, independent, dependent, and what does that relate to. Okay? So, here's the first example, something just to think of this in a different way before we start graphing. Solve the system equations by completing a table. Okay? So that's what we're going to do first. So what I would do, okay, just by making a quick table here, we have x plus y equals 3, negative 2x plus y equals negative 6. We'll call this one equation 1, and this is equation 2. And I'm just going to use y and a subscript for each one. Okay? So the deal is that when you find two lines across, that point of intersection is a solution for both equations. Okay? Individually, though, the line will indicate all solutions for one of the equations. Okay? So just kind of keep that in perspective. All right. We're going to plug some values in, and I'm going to tell you what values specifically, so we're not here all day. Okay? We're going to try 0, 1, 2, and 3. Okay? We're going to plug these numbers in, and the goal is we want to see the same output value. Okay? And why do we want to see that? Well, take a look at the picture of the lesson. This y value, 2, if I plug 2 into here, okay, and if I plug the x value of 2, this equation will equal negative 2, this equation will equal 2. It would satisfy both of them, okay? So when I'm looking at this, I'm trying to find an x value where it will give me the same output value, okay? Now I know in here you'll probably say, well, Mr. McCullough, this is negative 2, this is positive 2. That's not the same output. It is, okay? Both of them are giving me an output of 2 if I plug these two numbers into here, okay? These are not written in slope-intercept form. That's why it looks a little weird, all right? So just be cautious with that, but it's still a good question to ask. So I'm going to plug 0 into both of these equations. The first equation will give me a 3. The second will be a negative 6. If I plug 1 into both of these, I would get a 2 and a negative 4. If I plug 2 in, I get 1, negative 2. If I plug in a 3, I get 0, 0. Now looking at just this table, I can tell you that right here is my solution, okay? If I plug 3 for x into here, the y values has to be 0. And we can check, right? If I plug 3 into here, I get 3 plus y equals 3. So y has to be 0. If I plug 3 into here, I get negative 6 plus y equals negative 6. That has to be 0 as well. So the point, okay, 3, 0. That's where both lines intersect at. So that's a solution for both of them, okay? So by a table, it doesn't take long. I mean, you could use your graphing calculators, right? They have a table function on there. And if you put both of these equations in and look at the table, you're trying to find the same output value. So one way of solving it instead of graphing it, okay? Any questions? Comments? Concerns? Dilemmas? All right, so let's continue. So let's look at another example. So this one says, what's the solution to this system? What x and y value would make both of these guys true? Okay. So this one says, solve for y, then plug these into the calculator, look at the table. I have instructions on how to do this in the PowerPoint. Okay, so you can look at that. If you have a graphing calculator at home, you can go ahead and go through those steps to see that. Okay. So if these are my options. Now let's say you didn't have a graphing calculator handy, and this was on a state test. What would you do? Well, it's actually not that bad. I would take each point, plug it into both of these guys, and see if it comes out to be true. Okay? So, real quick, I'll tell you what the answer is, and then we'll plug them in, just for time's sake. So we have x plus y equals 2. We have x minus 3y equals negative 6. Okay? The point that will work is 0, 2. That's going to be my answer. Okay? That's going to satisfy both equations, and it's the point where they intersect. But let's check. Okay? Let's always check. So if I plug 0 into here, plug 2 into here, if I add them up, I get 2. That's correct. If I plug 0 into here, that's gone. Negative 3 times 2 is negative 6, which equals negative 6. We're good. Okay? So what you could do is you could take each point, substitute values, and see if it works. Okay? So not a bad method. So now let's actually get to graphing. All right? I've been talking about this. Let's actually do it. So let's see. We're going to have x minus 2y equals 0. X plus y equals 6. Okay. I'm going to, that actually hurt. I'm going to go ahead, I'm just going to put it right there. And I'm going to figure out where these guys intersect at, which is the solution, just by graphing it. Okay? And I'm going to try my best. This is not I measured everything, but still, it's more accurate if you have some grid paper. And I'll tell you what, use a different colored marker. We're going to use blue. So what do I do first? Well, if I'm going to graph this, I want to know what the slope is, the y-intercept. That increases accuracy, and that's what we need. So what I'm going to do is I'm going to take each equation and solve for y. So this would be negative 2y equals negative x. So I'll bring it over. So y would equal what? Negative, well actually it's a positive now. Positive a half x, right? So there's my first equation. I'll put a little 1 there if I want to differentiate between the two. Now over here, I'm going to do the same thing. So it's going to be y equals, be what, negative x plus 6 for that guy. All right? Not too bad, right? This will be a little y sub 2, just to say, hey, that's the second equation. Now, these aren't really bad. To be honest with you, you could probably come up with a number yourself that will work for both of these. Okay? So let's graph this. So let's graph the first one. We're going to start at 0. Okay? Then we're going to go up 1 over 2. Okay? And then we're going to go up 1 again and over 2. And then we're going to go the opposite direction. So down 1 over 2, down 1 over 2. We'll stop there. I didn't draw my line yet. I'll tell you why a little bit later. Okay. Now this guy starts at 6. So 1, 2, 3, 4, 5, 6. So right here. And the slope's down 1 over 1. Okay. And here's the idea. I'm going to keep doing this until these points cross. And if I have to draw more points to see that, I will. So down 1 over 1. Down 1 over 1. Down 1 over 1. Up. I think I might have found it. I think it's going to be that point, which is what? 1, 2, 3, 4, 2. I think 4, 2 is going to be that point. Now what I'm going to do now is I'm going to draw both lines just to verify. Okay, so there's the first line. Here's the second line. Okay. So right here, I'm going to make it more pronounced. Like I said, mine's a hand-drawn graph, so I'm going to do the best I can with it. I could put something on the computer screen here, but I want to show you the process, okay? So 4, 2 is where these two graphs intersect. So you see how I was just plotting points for both of them until they both had the same point? Then I drew my lines. I think that's easier to see. If you draw your lines, and if you don't draw them accurately, it's going to be hard to find that point of intersection. So that's just my recommendation. Okay? So what we're going to do is we're going to check to see if this will work for both of them. So here's y1. So let's go ahead and plug numbers in for that. So we're going to have 2 equals 1/2 times 4. Does 2 equal 2? I hope so. It's the same number. It should equal each other. All right, last one. Let's look at the second equation. Plug the values in. So 2 equals -4 plus 6. And yes, I get the same thing. 2 does equal 2. So that is going to be satisfied for both of those guys. Okay? You should always check your answer. Okay? Always check your answer. Okay, so here's more steps on the graphing calculator that you can do on the PowerPoint slides. Once again, if you have one, you can go ahead and follow those. It's not a problem. Okay, we're going to do another example. And let me get rid of this. And let me carefully get rid of this. I know there's probably other people out there yelling at me saying, you could use this, you could use that, it's much easier. I know. I'm stubborn. I'm going to do things my way. There we go. Just block those out. Okay. Let's do another example now. All right, so we're going to have these two. 2x minus y equals -1. 2y plus 5x equals -16. All right, and what we're going to do is we're going to graph both of those equations and see where they intersect at. Because that's my solution. Okay. All right. So, what I'm going to do first is I'm going to solve each one for y. So this one will get -y equals -2x minus 1. If I bring that over, divide everything by a -1, so I get 2x plus 1. I'll put a little 1 there, so that way I know that that's my first equation. Now I'm going to do the same thing over here. I'm going to bring this guy down and get 2y equals -5x minus 16. I'm going to divide both sides by 2. -5 over 2x minus 8. I'll put a little 2 there. Why some 2? Okay. I have my graphs. Now I'm going to go ahead and plot some points here. So this guy starts at 1. And then I'm going to go up 2 over 1. Up 2 again over 1. Up 2 again over 1. I'll stop there. And then I'll go the other direction. So down 2 over 1. Down 2 over 1. There we go. And I'm not going to draw the line yet. Not yet. Okay, next one. That's someone's coming to my door. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to start down here. And it's a negative sloped line. So it's actually going to go in this direction. Now notice, I'm not going to plot points in this direction because let's think about it. Is that going to intersect with this line if I go here? No. So I'm going to go in this direction. So instead of down 5 over 2, I'm going to go up 5. 1, 2, 3, 4, 5 over 2. 1, 2. Hey! That point works for both of them, huh? So I'm going to go ahead and draw my lines just to confirm that that should be, roughly be, where that solution is. There we go. Boop, 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 and boop. So there we go. So there's my solution. And that's going to be at -2, -3. Let me just make sure. Yeah, my notes agree. I'm always leery on drawing hand graphs. That's why I make sure that that's going to work. Okay? Questions? So we should check our work. So we'll go ahead and do that real quick. So let's check. So the first equation, all right, I'm going to plug in, and that is, wow, let me try that again. There go. Negative 3 equals 2 times negative 2 plus 1. So we get negative 3 equals negative 3. That's perfect. Okay, the second equation, let's make sure it works. So we get negative 3 equals negative 5 over 2 times negative 2 minus 8. I think we're going to get the same answer here. We're still going to get the same result, right? Negative 5 times negative 2 is 10. 10 divided by 2 is 5. 5 minus 8 gives me negative 3. So we're good. All right. Keep this in mind. When we get to substitution elimination, we'll talk about it. How many solutions does a system have? Right now, 1, right? You have 2 lines. So it should only be 1 solution, right? Or else it's no longer a line. When would it be infinite solutions? When would it be no solution? So, think about that. I think the answer isn't too hard to grasp, but we'll talk about it in the next lesson. We talk about substitution elimination. Okay? All right. So, reel this thing back. I want to look at a word problem together with you. Okay? I gave you the answer. No, I didn't want to give you the answer. I'm not going to graph this word problem. It's already graphed for me on the PowerPoint, so I'm going to use that because it'll be a little bit more accurate than me just hand drawing this. Okay. So it says here, a service club is selling copies of their holiday cookbook to raise funds for a project. The printer setup charge is $200, and each book costs $2 to print. The cookbooks will sell $6 each. How many cookbooks must the members sell before they make a profit? Okay? So, let me think about this for a second. You have 2 equations here. Okay? One equation is going to talk about what? The cost. The other equation is going to talk about how much money you're getting. Okay, which is always a good thing. So we're going to have a cost equation, and we're going to have our profit equation here. Okay, let me just switch this over. I don't want to find out when I close this video that you guys weren't able to see all my work. Okay. So for the cost one, well, it's costing me $200 no matter what. That's the setup charge. So plus 200 is what I'm going to have here. The cost for each book is $2. I don't know how many books, so I'm going to say $2 times X. So that's my cost. Okay, and I'll put a little sub 1 there just to differentiate a little bit. Okay, or you could just do a different variable if you like. Okay. Now my profit, I'll put Y sub 2 here. Each book costs $6. Once again, I don't know what the books are, so I'll put X. So 6 times X. Okay. Right, so far so good. Now, what I'm going to do is I'm going to graph both of these on an XY plane. I'm going to be specific, though, because I only want the first quadrant. I'm not going to look at negative profit, right? So I'm looking at the first quadrant. The X is going to be the number of books. So number of books. This is your Y, which is going to be your profit. Okay. There we go. Okay. And then we're going to go ahead and graph this. Sound good so far? All right. Now, I'm going to, like I said, I'm not going to graph this by hand because I don't want to mess up. So we're going to look at the PowerPoint slide where it is graphed for you. Okay. Honestly, I'd probably have like Desmos or something up here or just some graphic calculator that we plot together so you can see it, but I need the laptop to record. So my recording setup, I do have to improve in the future. So if we take a look, we're going to graph both of these. All right, and when we do, we see that they do intersect at a point at 50 and 300. Now let's interpret that for a second. X's represent books, Y's represent what? The cost or profit, depending on what graph you're looking at. So you need to sell, to make a profit, okay, you have to sell at least 51 cookbooks. say at least 51? Because remember, you always want to interpret, if you have a word problem, you want to interpret the answer. Let's go back to this guy right here. Okay? If I put in, 50, let's put 50 in, right? That was the point, 5,200. I believe that was the point of intersection, right? 5,200? No, 5,300, I'm sorry. 300. Okay? That's where both of these are equal to each other, right? That means your cost equals your profit. You're earning nothing. But let's see that actually written here. So if I put in 50, okay, that's $100 here, right? 2 times 50 plus 200. So it's going to cost you $300 to make 50 books. And that's the output, right? I'm just checking to see that this is good. If I look at $6 a book, that's 6 times 50, that's, once again, $300 I'm making. So to find the total profit, you're going to subtract out your cost. This is my cost. This is your profit. So that means I'm earning nothing. Okay? So if I'm trying to do a service to the community and I want to sell these, well, I need to make more than $0. Okay? So I need to sell these 51 books. Okay? Any questions on that? It's just a quick little analysis with it. Okay? All right, last thing I want to show you is the types of systems that we can have. So this is actually working out well. This will be a good part 1 video. Okay? So you want to write these down. These are just descriptions. Okay? This is describing what type of system you have and what the graph's going to look like. We have a consistent and independent system, and that's what we were working with today, right? All of them are consistent and independent. So they have one solution, okay? Consistent dependent is one that's the same line with infinitely many solutions, okay? So what happens is you might come up with 2 equations, but they're technically the same line, okay? And we'll see that in the next video. And then we can have an inconsistent system, which means that they're parallel lines. There is not one solution that will help both of them. Individually, they have infinitely many solutions, but together they don't have one that works for both of them. Okay? So once again, these are just characteristics of linear systems, and we'll talk about more of these in that next video. Okay? That's it. That's just graphing. So not a long or difficult concept, but one that just kind of introduces systems. So we're going to start that, and then, like I said, I'll upload the next video, which will be substitution elimination. Okay? And after that, we can actually start building on some more with this and throw some more Algebra 2 stuff in there. Because so far, this is just a review from Algebra 1. Okay? So thank you for watching. Hope you guys have a good day. See you in the next lesson video.